Okay, our first theorem that we're going to look at is the tangent to radius theorem. So what is the tangent to radius theorem? I'll give you a minute to copy this definition down, the picture, and then we want to have in the picture a radius with a tangent line. So the tangent to radius theorem is that a radius will always be perpendicular to the tangent line. So a tangent line again touches the circle at one point. It's a line that touches the circle at one point, and if you have a radius that intersects with the tangent, it will be perpendicular to the tangent line, meaning it will form a 90-degree angle with a tangent line, which is going to open up lots of possibilities. For example, Pythagorean theorem. So I will give you a moment to copy this example as well. We're going to say that JL is the radius of circle J, and we want to determine if KL is tangent to circle J. So go ahead and pause the video, copy this example down, and we'll work it out together. So if KL is in fact tangent to circle J, then this would be a 90-degree angle. So the question is this a 90-degree angle? Which can be answered by proving that this is a right triangle, which can be answered by proving Pythagorean theorem. So one little trick here is they're just giving us 9 from K to this point on the circle. We actually have to figure out what the whole segment JK is, which isn't hard to do because they've drawn a radius here from J to the circle. So from J to the circle is another length of 8. And 9 plus 8 is a total of 17. So now we have a right triangle, or what we think is a right triangle. That's what we're trying to prove. So we want to see if c squared is equal to, we're asking the question, is c squared equal to a squared plus b squared? Our c, as you know, is always directly across from the 90-degree angle. So I'm asking, is c squared or 17 squared, is it in fact equal to 15 squared plus 8 squared? 17 squared is 289. Now, does that equal 15 squared, which is 225, plus 64? Well, let's add it up. 289 does in fact equal 225 plus 64. It equals 289. So yes, JL is tangent to KL because, or JL is perpendicular to KL because it fit into Pythagorean's theorem. So now you will determine the same thing in this next example. Again, they're only giving you from H to this end point is 12. So in order to figure out what the whole length of HF is, you want to figure out the radius of the circle and then add the two lengths together for Pythagorean theorem. So go ahead and pause the video and see if you can determine whether GH is in fact tangent to circle F. So a sample response, no is the definite answer, but a sample response would be that no, because 18 squared doesn't equal 8 squared plus 6 squared. If you didn't understand how I came to that answer, go ahead and raise your hand and we'll be happy to help you. Okay, and we're going to do one more example pertaining to a radius and a tangent, and that is actually using Pythagorean theorem. So it says, find the value of x, assume that segments that appear to be tangent are tangent. Let's put a little t here. Sneak that little t in there. So if AC is the radius and BC is tangent to the radius, then we have our right angle here at angle C. So in order to find x, we are using Pythagorean theorem. So c squared equals a squared plus b squared. So our c is always directly across from our 90-degree angle. That would be 17 squared. And we want it to equal a squared plus b squared. And we don't, it doesn't matter what you call a and b. I'm going to call x squared our a squared plus 14 squared. Okay, now 17 squared is 289. That's going to equal x squared plus 14 squared, which is 196. We'll go ahead and subtract 196 from both sides of our equation. And we will come up here. 289 minus 196 is 93. That equals x squared. So we'd go ahead and take the square root of both sides. So we get x is approximately, I'm going to round to the nearest tenths on this one. So x is approximately 9.6. Okay, and the last theorem that we're going to talk about is the congruent tangents theorem. And that is just that if you have two tangents that are touching on the outside of a circle, then they are congruent tangents. So if two segments are tangent to a circle, so we have a tangent point here and a tangent point here, if these two segments are tangent to the circle, then they have the same exterior point, then they are congruent. So we can say that segment AB is congruent to segment CB. That's because they both have the same exterior point and they're both tangent. I call this the ice cream cone because if you have an ice cream cone, your cone, ooh, that's awful. That's a little better. But your cone has to be even on both sides, or else if you had something going on like this, your ice cream would fall off the cone and it would be all over the ground and you'd be sad. That would be you, sad. So in order for the ice cream cone to stay on the cone, these two sides of the cone have to be equal to each other. So let's go ahead and see how this works in an example. So if AB and CB are tangent to circle D, then we want to find the value of x. So again, this is the ice cream cone. If these two are not congruent, then the ice cream wouldn't stay on the cone. So we want these two to be congruent. So to find x, we are going to set the two expressions equal to each other. So x plus 15 should equal 2x minus 5 in order for our ice cream cone to keep the ice cream up on it. So what I'm going to do first is add 5 to both sides. Whoop. So x plus 20 equals 2x. And then I can run out of room here. I'm going to subtract x from both sides of my equation. So I get 20 equals x. So now I'd like for you to do this last example on your own. Get rid of this for you. And we're going to find the value of x if the two segments are tangent. So nice and simple. If the two segments are tangent, then their expressions will be equal to each other in order to find x. So go ahead and pause the video and see if you get the same answer that I do. Okay, so I got x equals 3. If that's not what you got, go ahead and raise your hand and one of us will be happy to help you.